In exercise 12.04, we're going to have a look at stopping distance. Now, most of you are probably learning to drive. Some of you may already have your license. And you would be aware that if we talk about needing to stop the vehicle, then you know that from the time that you decide the vehicle needs to stop until it actually does stop, there is a certain distance that the vehicle will travel. So we talk about this as, or we refer to it as the stopping distance. Now, there are two components. There are definitely two components to that distance. And they may be concepts that you haven't really thought of. But you know, as you're driving along, if something comes up in front of you and suddenly before you see something like a rabbit, a bunny, then you know that maybe initially you're shocked, but at some stage you put your foot on the brake. Now, and even when you put your foot on the brake, the car doesn't automatically stop. So we have two things happen. You have a reaction to seeing this object, knowing you need to stop. And then you have the actual car physically using the brake to stop the car. So we have a reaction, the time or the distance the car travels from the time you observe this thing until you actually get your foot on the brake. And that might be, less than a second, but the car is going to travel some meters, depending on your speed, in that 1 second. And then the car is still going to continue to move and cover a distance until the brakes can effectively stop the car. So I'm sure you can understand this concept of stopping distance having two components, a reaction distance that it's travelled and a braking distance that it has travelled. The reaction distance is calculated. Distance, we know that distance is speed times time. We've done that, we've used that formula many times before, that distance is equal to speed times time. Now, that works perfectly for this reaction distance. There's no other factors that need to be considered. The thing that determines how far you go is the time it takes you to put your foot on the brake and the speed at which the car is going. So your reaction distance is calculated using the speed the car is going at and your reaction time. The faster you're going, the bigger the distance. The longer the time, the bigger the time it takes you to react. Again, the bigger the distance you'll travel. Anything that slows down your reaction time, for example, alcohol, mobile phones, because you're not concentrating, it's taken you longer to react, other people in the car distracting you, it's taking you longer to react. That will all impact on the distance that you travel. The braking distance isn't that simple, and we're usually given a formula for calculating the braking distance. And there are many factors that influence the braking distance. Obviously, the speed of the car is one, the quality of the brakes, the surface of the road, the quality of the tyres to actually grip the road. So there are many, many factors. And so we're just going to simply say for braking distance that it is k times v squared, where v was the speed of the car that the car was travelling at, and k is just some constant. Now, if k isn't given, there will be other information given that we can work k out. Okay, so what's important is that your total stopping distance made up of two components. Let's have a look at these examples, and we're going to use our problem solving techniques where these are obviously problems. We need to read through them a couple of times, highlight important aspects, and then attempt our solution. So it says, what is the stopping distance? So that enables me to write, find stopping distance. Now, what connection do I make when I see those words? Well, if I've learnt and paid attention to this concept here that says the stopping distance is your reaction distance plus your braking distance, you'll be looking at this thinking, for me to get the stopping distance, I have to know the reaction distance and the braking distance. Now, that all becomes well supported when you read the part A of the question. The reaction time distance, the reaction distance is 25 metres. Well, that's one component of it. And then the braking distance is 22 metres. So as you can see, the stopping distance requires nothing more than adding two numbers together. It's equal to this reaction distance of 25 metres. The car actually travelled 25 metres before the person was able to put their foot on the brake. And then when they put their foot on the brake, the car still went another 22 metres. So all up, 47 metres. That's quite a distance. Now, part B is a little bit different because still asking you for stopping distance, find the stopping distance, and so I'm aware that I need the reaction time distance, whereas they only give the reaction time, the time. It's in seconds, whereas this measure here that was given was in metres, and this was in metres. So why have they given me time? Time is equal to 0.75 seconds, and travelling at a speed of 60 kilometres per hour, seconds, hours, that's a problem. However, they've made it easier here. They've said the braking distance, I like that, is 27 metres. I don't have to do any calculation with that. But with this, I've got a lot of calculating to do. To find this reaction distance travel, distance is speed times time. The speed is given as 60, but they're kilometres per hour. Now, I don't have an hour. I'm not going to go 60 kilometres. I only have 0.75 of a second. I don't even have 1 second. How do we convert seconds to hours? You will need to divide To start with, we multiply because the formula says now to get the correct time unit, I want 0.75. To convert my seconds to minutes, I divide by 60. Now that gets it into minutes. Not to be in minutes, I have to divide by another 60, which you put underneath in a bracket and you multiply. And when I do that calculation, so the 60s cancel out, one lot of 60, and do this calculation, I get this decimal. Now I really have to be thinking here, because my speed was in kilometres, this distance unit is kilometres. Now I know I can't add kilometres and metres, simply adding them together. I have to convert these kilometres to metres. To convert your kilometres to metres, you will multiply by 1,000 and you'll get 12.5 metres. Therefore, the total stopping distance is my 12.5 plus my 27 metres, which gives me 39.5 metres.